Hello, friends. I welcome you to my data analysis in SPSS series. My name is Dr. Lohua Mahmoudou. Today, we are going to have a look at performing logistic regression analysis in SPSS. Now, we know logistic regression analysis is used in assessing the association between an outcome variable and giving certain covariates or independent variable. Quite often, logistic regression have been used mostly in health science research or public health research, particularly when it comes to survey data analysis or cross-sectional data analysis. So without wasting much time, let's get to it. Now, once you have your data into SPSS, or you have already imported your data into SPSS, you've done all the necessary data cleaning. If you want to perform logistic regression, what do you do next? So this particular data, let's look at a little bit about what this data involves. So if you go to the variable view, this data is a data given on, we have about diabetes, hypertension, whether or not the individual have history of smoking, certain cholesterol, obesity. So these are information we have in the data set. Now, our research question, or what we want to do, is to actually investigate the association of factors to diabetes. So we want to analyze and find out what are the factors associated with what diabetes, or what are the risk factors associated with diabetes. So we have diabetes as a variable here, which is given by, if you look at it, we have, it's a binary variable. So we are going to use the binary logistic regression. So we have 0 as no, and then 1 as yes. So 1 means there's a presence of diabetes in the patient, and 0 means there is no diabetes. And then we have all the other variables we will be choosing from as our covariates or independent variable in performing this regression. We have, for instance, age is given in this form: 45 to 54, 55 to 64, 65 to 74, and 75 plus. So this is how age was being categorized. So given this information, we want to perform our logistic regression to establish or identify factors that may be possibly associated with obesity, diabetes. So let's get to it. So in order to perform logistic regression, we click on Analyze, and then we go to Regression. So once you click on Regression, there will be a drop-down menu. Then within the drop-down menu, you go all the way down to Binary Logistic. Now remember, we have multinomial logistic here. Multinomial logistic regression is when you have your outcome variable having more than 2 outcomes or categories. But over here, we are going to make use of the binary logistic regression because our outcome variable have only 2 categories or groups. So now we click on binary logistic regression. Then in the logistic regression, we have over here, which is the dependent variable. And then we have the covariates or the independent variable, or in some cases, some people refer to as predictors. So let's first of all perform a simple logistic regression, or what some people call it a single variable logistic regression. Now we have diabetes as being our outcome or dependent variable or the target variable. So we put it into the dependent variable. Then let's say we would want to see whether there's an association between the blood pressure and then diabetes. So we put blood pressure in our covariates. So once we are done with that, we can go to the option and then categorical covariates. Now blood pressure is a categorical variable which was given in, I think, which has about 2 indicators. So we have the hypertension, hypotension, and then others. So we put it here, which is a categorical variable, then we leave it. So over here, we have the indicator. This is where you actually have to specify, but here you don't do anything. Let us leave it as it is. We leave it as indicator because it's an indicator variable or a dummy variable. So now we go to continue. Then also, even before we continue, if you look at the reference group of, we always have the reference group, which is reference group that first and then the last. Now, what SPSS does is that now it's actually used by default. SPSS use the first or the first coded variable as your reference group in every analysis. So now you can also change it as to be your last variable to be the what reference group. So whichever way you would want to set your reference group, SPSS gives you the option to code your first variable as the reference group or the last variable as the reference group. So let's leave it as it is. So bear it in mind that once you are performing a logistic regression analysis in SPSS and you have indicator variable, SPSS by default use the first coded category of your indicator variable or your covariate as the reference group. So let's go continue. Then we also have what is called the option. So the option gives you the option to select certain analysis you might want to perform, but we wouldn't want to see any of these, with the exception of we have the confidence interval of the odd ratio. Now you remember the exponent or the antilog of the beta or the coefficient represent the odd ratio of the covariates within a logistic regression. So we want to see the confidence intervals of these covariates or the independent variables. So now we keep everything as it is. And then if you want to exclude the constant variable, you can click on and then uncheck this box. But if you want to include the constant variable, then you have to check this box. So we want to include the constant in our model, so we leave this box checked. Then we go to continue. Then we now also go to OK. So once you go to OK, this is the results in which SPSS have produced. So first of all, you have the case processing summary, and then you have your dependent variable, which is the diabetes, and yes, representing the individual have diabetes, and no, the individual is not having diabetes. And then the case processing tells you if there is any missing cases within your data, which we don't have. So that's good for us. And then you have the categorical variable coding. So with this categorical variable coding, you can see we have the that's the covariates. So we have hypotension, which actually represent our reference group. And then we have the normal blood pressure, and then we have the hypertension blood pressure, which is given. So we have three categories of the blood pressure. And then our indicators are given by the normal and then the hypertension, with the hypotension being the reference group. So now if you go forward, we also have what is called a classification table. So the classification table allow you to be able to sometimes assess the sensitivity and then the specificity of your prediction. So we wouldn't look much into that. And then this is the variable equation. So over here, it only gives you the constant variable. And then we have the variable not included. So these are variable selection processes it actually gives you. So we leave everything as it is and then go straight away to this table. So anyway, let me also show you, we have the model summary. So the model summary actually also tells you the effectiveness of your model in through the prediction processes. So we have the Nagel KK R square, which actually it's also performs similar function like the R square we know in ordinary regression analysis. And then it actually tells how effective the model is being, but we wouldn't want to look into any of this so much. So this now is the output you'll be looking at. This last output is the output you'll be looking at for your logistic regression model. And then in this output, so So this is the case selection. So in this last output, we have the variables in the equation. So this last output actually gives you the output for the coefficient. So you have the second column. So the first column gives you the variable names, and then which is the high blood pressure, which is the first high blood pressure indicator was representing the normal, and then the next one was representing the hypertension, and then the hypotension was the reference group. Now remember, you will not have any, you will not be given any output for the reference group, but rather when you are to make interpretation, you make interpretation by comparing those groups you are given to the reference group. And then also we have the constant here. So this represents the coefficient. The B here you see represent the coefficient. And then we have the standard error of the coefficients. Then we have the wild test. And then we also have the degree of freedoms. We have the significance. So the sig here is representing the p-value. And then we have the expected beta, which is representing the what? The odd ratio. So we have over here to be the p-value. And over here to be the what? The odd ratio. And then we have the confidence interval of the odd ratio. So this one is given at the confidence interval of the odd ratio, which we have the lower bound and then that of the what? The upper bound. So you have the lower bound of the confidence interval, and then you also have the upper bound of the confidence interval. So this one is given at the confidence interval for the odd ratio. So this one is the confidence interval for the what? Of odd ratios. So now the question now becomes, how do you actually make your conclusion based on this information? So based on this information, we can actually make the conclusion using the p-value. So for instance, the p-value of, how do you call it, of the blood pressure one, which is representing the normal blood pressure, is significant. And then the p-value for the hypertension, which is the which was the second indicator of the blood pressure, is also significant. Because if you compare it with alpha level of significance, if you have to choose an alpha level of significance, usually which is 0.05, then that actually tells us that the p-value for the normal blood pressure is less than 0.05. So given that the p-value of the normal blood pressure is less than 0.05, we conclude that there's a significant difference between the normal blood pressure and the reference group, which is the hypotension group, regarding the influence on diabetes. So there's a significant difference. In other words, we can also conclude that there is an association of individuals with normal blood pressure on diabetes, or normal blood pressure is associated with what? Diabetes, given that you have this small p-value. So again, if you also take the hypertension group, you can also say the hypertension group is also statistically significant, given that the p-value is 0.01, again, less than the level of significance. So we also conclude that hypertension is associated with what? Diabetes. And then also we can also conclude that there is a statistical significance between the hypertension group and then the hypotension group, which was our reference group. Now remember, the reference group is representing the what? The hypotension, which was given here as the reference group. So now, if you look at the odd ratios, how do we actually interpret the odd ratios? So if you take the odd ratio for the normal blood pressure, which is the normal blood pressure for the odd ratio is given by 0.715. So, and which is less than 1. So given that this odd ratio, when odd ratio is less than 1, how do we interpret? So if you have an odd ratio which is less than 1, it means that there is a positive, there is a negative association between normal blood pressure and then diabetes. So if there is a negative association between the normal blood pressure and diabetes, how do you actually estimate this negativity? So it also means that there is also, since the odd ratio of the normal blood pressure is less than 1, there is a decrease odds or likelihood of an individual with normal blood pressure having diabetes. So if that happens, then by what decrease are we actually referring to? So to know the decrease, by taking the odd ratio of the normal blood pressure, you subtract it from 1. So 1 minus 0.715, which will probably give us that probably give us 0.285. So with 0.285, if you multiply it by 100, that is going to give us what? 28.5%. So what it means is that an individual with normal blood pressure has 28.5% decrease association. So an individual with a normal blood pressure have 28.5% decrease association or likelihood of getting what? Or hypertension. And then if we take hypertension odd ratio, which is the hypertension group, which also showed to be statistically significant, significantly associated with the diabetes. And then it also shows that there's a statistically significant difference between the hypertension group and then the reference group, which is the hypotension group. So we have the odd ratio of hypertension given by this, which is 2.982. So given that we have 2.982, and then the odd ratio of hypertension is greater than 1, it means that there is a positive association of hypertension with diabetes. So if there is a positive association of hypertension with diabetes, it also means that an individual with hypertension have an increased risk of being diagnosed with diabetes or getting diabetes, right? So if that happens, how can we evaluate this increment? What is the value of this increment? So in order to do that, we take 2.982 and then subtract it from 1. And that is going to give us 1.982. So with 1.982, if we multiply it by 100, that is also the same as 198.2%. So what this implies is that an individual with hypertension have 198.2% increased risk of being diagnosed with diabetes compared with an individual with hypotension or compared to the reference group. So there's how you actually interpret the odd ratios. Now, given the confidence interval, you can also look at the confidence interval to make conclusion on whether there is a statistical significant difference between the covariate and the reference group. So for instance, if you take the odd ratio of the second blood pressure group, which is those with hypertension, the confidence interval of that odd ratio is given by this, right? So the lower bound of the confidence interval is 2.3, which is actually greater than 1. So if your confidence interval does not include 1, then it means that the that variable is statistically significant. Hence, we say hypertension is statistically significantly associated with what? Diabetes. The same way, if you take the normal blood pressure, the normal blood pressure is giving us an confidence interval of this. Again, if you look at this confidence interval, the confidence interval does not include 1. So again, it tells us that an individual with normal blood pressure is statistically significant associated with what? Diabetes. And then also there's a statistically significant difference between a normal blood pressure patient and then a patient with hypotension in terms of their impact on or the incidence of getting diabetes or developing diabetes. So there's how you can actually interpret some of these. You can interpret the statistical significance by using the p-value or by using the confidence interval. And then you can also interpret the odds ratios by knowing to what extent is the impact of the independent variable or the covariance on the outcome variable. So I hope you enjoyed this. And there is a simple logistic regression or one variable logistic regression. And the only variable we have in that logistic regression, I think we have was hypertension. And in order to write out your logistic regression equation, you should be able to have, so we have the logistic regression equation given by p hat and then 1 minus p hat. So what are our covariates? Now, given that we have, there was two indicators for our categorical variable because it has 3 categories. Hence, one was used as reference group and then leaving us with 2 indicators. So in order to write out the logistic formula, you are going to make use of this. So we have our constant variable, which is negative 2.758, then minus, so we have then minus, we have 0.336 times that giving us what the normal blood pressure, and then also plus 1.093, and that is what the hypertension blood pressure. So this becomes your regression model. Now I might emphasize that given that we have these variables as our covariates, now this actually makes this regression a multiple regression because our indicator variables were 2 indicators and 1 reference group, it gave us 2 covariates, making this particular multiple logistic regression. So there's how you actually assess logistic regression. And I will see you in another section where we are going to expand this to include so many variables within our data. So see you there, and I hope you enjoyed this section. Thanks for watching. Bye-bye.